Hey everyone, my name is Omar Masika. I'm a Director of Solution Engineering at Granulate. Granulate is a startup company that was acquired by Intel about 6 months ago. On our session today, we're going to discuss basically how to integrate cost optimization and autonomous optimization into your cloud cost journey. Basically, we will cover whether you are currently migrating to the cloud, deploying a new application, or however you're currently trying to squeeze out more cost efficiency out of your cloud, we will try to make sure that you're able to do that in a more efficient way. Basically, I argue that whoever is deploying or in charge of that deployment of new applications is going through a similar state of mind process, which is specifically tied to cost. Basically, when you first deploy a new application, you are willing to invest much more resources or pay much more money because you are more willing to make sure that the application is running. You are optimizing for availability, and then you're willing to spend a lot more than you will spend a few months down the road, and you feel more confident with your application. So we'll go through how we think you should incorporate autonomous optimization to make sure you're moving down that road faster. And I'll also cover Granulate, which is the company I'm from, the tools we offer, and our vision into how you can incorporate those tools and immediately provide more cost optimization, more performance optimization into your existing processes. Cool. So let's talk about that state of mind. I use the Maslow hierarchy of needs just to make this come to life. But basically, I argue that when you start a new application on the cluster, you are at the lower end of that hierarchy. You are just trying to get the application up and running. And then throughout the process of deploying the application and feeling more comfortable with it, you're going up the pyramid and reaching to more self-actualization processes. So let's go one by one, and I'll try to explain. So we'll start with psychology. This means you're currently at your most I would say risky or afraid state. You just want to get the application up and running. You're willing to invest much more resource in terms of reservation, or you don't really mind about costs, just trying to get the application up and running. This may mean prepare your platform, reserve much more resources than required to ensure availability. This will most likely be happening by the dev teams. And then you're trying to get the application just up and running and start running with it on your cluster. After the application is up and running, you'll make sure you have safety and security. This means, from our perspective, maybe make sure that there is a smooth transition between adjacent application and your application, making sure that the code is written without serious bugs. You're still in a process of making sure the application is running as intended and is not really causing any issues before you're actually scaling it out and meeting actual customers and demand. So the next step will be love and belonging, I call it. This means the first time the application actually meets customer demand. This can mean it meets actual customers. It could be a big data workload meeting actual data sets, or any other application meeting internal needs. In that part, you're trying to look at how this actually scales to meet the demand. You're looking at your auto-scaling policies, at your thresholds, looking at your capacity in general, and trying to basically reach a point where the application can meet the demand as it should and provide the service that it's trying to do overall. Now we're moving to self-esteem. This means now is basically the first time, regardless of your size of your infrastructure or company, that you're trying to look at costs. Now the application has met its actual demand. You are scaling it out to meet that demand. And now you're trying to understand, why am I doing wrong with my costs? Am I paying too much? Is it efficient enough? Maybe try to check reliability in a continuous way. You're basically trying to first understand whether this application is actually worthwhile in terms of business goals or cost. And then only after you went through all those processes, you reach the most advanced. Now your application is up and running. You feel confident about it. You know you want to create more cost optimization. And now you're looking at the more advanced capabilities. This may mean let's do code rework. This may mean renegotiate your cloud EDPs. This may maybe you're doing configuration tuning, making one-time changes to your parameters in a kernel level to improve performance. All of those are a bit more advanced and will most likely cost you more efforts to reach less cost reduction than before. If the initial cost reduction efforts are a bit lower end in terms of efforts, now we're reaching a more complex and interactive optimization. So basically, where this cost optimization or hierarchy of needs meets your actual cost, all of those pillars of the hierarchy are translated directly to cost optimization efforts. So when you're in the first phase, you're just trying to get your application up and running, it will most likely be manifested in visibility tools. Maybe you'll check in your APMs, you're making sure the application is running. You're using cost tracking, or maybe having alerts if the application has bugs. maybe actionable alerts if your costs are going up, just making sure application is up and running as functioning as intended. Then when you feel a bit more comfortable, you go into awareness. I'm aware of my costs. Now I'm trying to go for the low-hanging fruits, maybe saving plans, EDPs, maybe I'm moving to spot instances or reserved cores, maybe I'm using best practices in my code development. These are, again, a bit of low-hanging fruits you can implement immediately to reduce your costs pretty easily. Then once you finish with that section, you move to management. Now you know your costs, you know your problems, and you're implementing a bit more complex solutions. So this might be right-sizing solution, reserving the correct amount of resources per pod or per node, maybe turning off machines which are underutilized, maybe getting a team up that just manage the costs and IOPS. Either way, you can see on the right side, this is a more high effort and out of the cloud. Most of the solutions on the awareness and visibility, cloud AWS specific, and can provide to you pretty easily. But then you're trying to move away from that to a more complex and managed services, and which will require most of the times a bit more manual work. If I'm saying right sizing, in your head, I believe you're thinking, okay, I need the DevOps team to look at any resources requested or used by a pod or service, and now we need to manually make the changes, which is a lot of manual effort. And then we move to the last phase, which is optimization. I mentioned this is, again, a bit high effort, but might provide potentially cost reduction, negotiating your contract, workload migration to the specific service in AWS, which is more relevant to you, etc. Again, these are more in the high effort end of the spectrum when you try to achieve that extra percentage of cost reduction and performance optimization. And when you look at the hierarchy of needs, basically, when you start off, we look at like a graph, a basic graph of your relative size or cost of your infrastructure at the beginning of the hierarchy. When you're at the bottom of the hierarchy, you are willing to pay much more on the relative size of the infrastructure or cost you're paying because you're more interested in availability. And as you push towards that top end of that hierarchy, you're moving towards a sweet spot. Sweet spot meaning this will not, I will not invest more resources because the cost reduction I will get out of it might be low and not worth the while. So either way, you are on that graph. If you are a very well optimized company, you might be on the right side. You're already on the sweet spot. You have diminishing returns for investing more resources. Or you may be a small company, a startup company that is only interested about growth. You don't care about that sweet spot, and you just want to make sure the application is running with high availability. Either way, you are stuck at some point by your own mental state of the application, or just unable to push forward down to more optimized status because effort is way too high. Just to show you, this can translate to, if you're a startup company, you might start from a very high position because you're willing to pay much more to make the application up and running and take you longer to reach that sweet spot. Or if you're an enterprise, you might start off low because you're more planned out, but you will still reach that sweet spot pretty quickly. Either way, you reach some sort of threshold. Also, for migration, you might have already went through optimizing your backend or standalone or on-premise deployment, and then once you migrate, everything goes to hell. You need to start over and start optimizing your code and cost reduction to achieve better performance. So either way, as I mentioned, you are reaching at some point a saturation. You are no longer able to invest more resources to efficiently get more cost reduction because you get diminishing returns. If I will ask the DevOps team now to make code rework of the dev teams, it will cost you so much work, and the potential cost reduction at the end might not be beneficial. Or if I will ask the DevOps team to now make a reservation effort, this might look small, but might take you a couple of months of actually understanding your cluster before you can actually see any potential cost reduction, and that might be low or not high enough. And you exhaust your resources. We all know how important right now is cost optimization for a lot of companies. And there's a lot of heat on DevOps and dev teams to reduce costs. You are throwing them on a lot of resource executions to try and reduce costs. And this is most likely not even worth it. You are investing a lot of team members on a lot of projects and eventually getting not a lot of cost reduction. And also, the last point is that further optimizations are bit of samey, because when you try to get more cost reduction, you usually look at the same bucket of cost optimization tools. Maybe orchestration, maybe right sizing, maybe some code reworks, maybe EDPs or spots, but that's pretty much it. If you've already done those, it is very hard to get additional cost reduction out of the position you're in and you feel stuck. There's no really a good way to move forward and reduce your costs. So now after we went through the mental state, how that mental state actually integrates with your cost optimization efforts and your saturation. Again, the saturation point can reach higher up the graph if you are a startup or lower. Either way, you will reach a point where it's not worth to invest more resources. So now let's talk about our suggested new model or vision into looking at this process, and how we can optimize that. So I'll touch quickly about the Granulate scene of autonomous optimization and basically how I think you should look at it moving forward. So the goal here is to try and integrate optimization tools and visibility into every step of your process throughout the development of application and the deployment. So we start from application profiling and analysis. This means continuous and aggregative look at your code and basically your functions and processes, and try and identify during the deployment and development of the code inefficiencies and bottlenecks to improve performance. These will help you get small land grabs along the way to solve major bottlenecks in your code and improve performance dramatically, which when you look at the sweet spot might help you go down that sweet spot faster or maybe reduce it even further. We then look at continuous optimization. Granulate provides, for example, a real-time continuous optimization tool that basically allocates resources better at the OS level, not reservation per pod or per node, but we look the approach to reduce costs that we see is improving performance. If the application performance is better, you will have more leeway, more space to reduce capacity and save your costs. We'll touch on each of those in a second. And then at the end, when you get performance optimization, you can also leverage capacity reduction tools, whether automatic or actionable insights. But now when you have that leeway or lower consumption of resources, there is more room to reduce your cost with those tools because you already have some space to reduce capacity, change instance types, or even run more load on the same instances you've already purchased. But that assumption is to, again, profile code to optimize on the go, optimize your OS level resources to get an additional maybe 30, 40% of improved performance from your saturation point, and also use the capacity management tools you might have to reduce additional costs. So when you translate this to Granulate tools, we're looking at three major tools. The one on the left you see is called GProfiler, and we'll go through any one of them in a couple of seconds. The GProfiler is a tool that basically allows you to profile your code in production in a continuous manner. You'll be able to get visualization into your code and identify inefficiencies. Maybe you have a line of code that is costing you a lot of resources. Maybe there is a configuration that you misconfigured in your Kubernetes or your code in general. Maybe your handoff between kernel syscalls and your Python application is inefficient. You can find ways, the dev teams can find ways during the CI/CD process to make the code more efficient without needing to rework everything and waste a lot of efforts. The second tool, which is the major functionality of Granulate, is an agent, a real-time optimization agent, which I mentioned allow you to improve performance out of saturated situations. Even if you already use spot instances, use reserved instances, already did right sizing and improve performance, you can still get an additional 30% from that tool, and we'll touch on that in a second. And then we also provide gMaestro, which is our tool that allows you to do continuous capacity management of your cluster. Basically, you set a logic. Let's say you want to maintain your reservation levels at 30% over the utilization over time. And then that tool maintains that suggestion or that logic over time without you needing to invest manual efforts into constantly change your reservation levels. Because basically, you all do it by the same logic over time. And we'll look at that in a couple of seconds. Cool. So we'll go over each of those tools and see how it integrates with your general processes. So we'll start with the agent. So let's start from the back. Granulate is a real-time continuous optimization solution. So we help companies handle their workloads with improved performance and reduce costs of between 20 and 50%. The technical premise behind all of our solutions is that operating systems were designed as a general purpose solution, which is supposed to support many different scenarios. This could be a user behind a keyboard, production environments, or any other scenario. And to do that, they're optimizing for interactivity and fairness between the different tasks and services running on the machine. So when you try to allocate resources that way for production environments, which behave very differently, they need to act on specific tasks and services in a very high pattern to performance scale, you get inefficiencies in the way operating systems allocate resources. And it might cause you to allocate resources in an inefficient way or utilize resources you don't really need at the OS level. So what the solution is agent-based. The agent is deployed per node in your cluster. This could be a Kubernetes nodes, VM, Fargate, EMR, however you're deploying what workloads you are running. And that agent will start by learning the workload. When I say learning the workload, the agent is comprised of a runtime module. This means JVM, Python, Golang. For each of those, the agent can learn resource allocation queues at the OS level. So thread level scheduling for JVM, or Go routines, route allocation of resources, or Python GIL. Each of those, the agent can learn the queues in real time. Let's give an example. This could be thread level scheduling on JVM. It is managed at the queue level. The agent can learn that queue over time, identify patterns of, for example, which thread costs what resources over what period of time. And then after all of those patterns are learned over a couple of weeks, the agent can actively reprioritize resource queues to achieve the best scoring patterns found during the learning phase. So the ending result will be you can run the same application, same workload, same functionality, just with the least amount of consumed resources required to achieve the same goal. And therefore, you are running with lower consumption of resources. You can either trigger your auto-scaling policies, because you're auto-scaling most likely based on a performance metric, or reduce capacity manually based on that free up space. So let's look at how this tool actually comes to life. I'll show you a quick live demo. I live dangerously, so I hope it works as intended. We'll try to see how this the agent actually provide performance improvement, and then show it on live. So let me just switch here. Yeah, I practiced it all afternoon. Cool. Awesome. Yeah, I see that you see my screen. What you're seeing here is a real-time bidding app. It's a bidder service written in Python. Basically, you see here 5 machines on one availability zone on AWS, which are receiving requests from 10 machines on another availability zone. Just to show you the metrics, I know it's a bit small, but I think you can see it. Each machine is handling about 120, 122 requests per second. The P90 latency is averaging, it's me, between 48 and 57 milliseconds. P50 latency about 35, 36, and CPU utilization is steady at about 60 to 65%. So what I'm going to do right now is I'm going to log into one of those machines, and I'm going to activate the agent on one of them. Just as a reminder, what happens when I activate, the agent will start making that changes to OS level resource consumption and allocation to relieve bottlenecks and improve performance at the queue level. So I'll log into one of the machines. Yeah, I've logged into machine number 168.1.197, which in this example is the blue line over here, 168.1.197, and I'm going to activate the agent. Just as a reminder, I mentioned that there is a learning process where the agent identified the repetitive patterns before it's ready to be activated. But because this is a demo, it's already pre-learned, so I can immediately activate. But what should happen right now is hopefully you'll be able to see that the blue line will start behaving differently from the rest of the machines because of that change in resource allocation at the OS level. So you can immediately see that it behaves differently. There is a significant drop in P50 latency to about 24 milliseconds compared to the 34, 35 of the rest of the machines. You can see the P50 latency also dropped to about 41 milliseconds compared to the 44 or 48 of the rest of the machines. And because this is a least connection load balancing cluster, the load balancer just pushes more requests into that machine, and the blue machine is handling about 143 requests per second. What I think it's most interesting here is that although this blue machine is handling more requests faster, you would assume that we'll be consuming more resources in terms of CPU. But as you can see here, CPU utilization maintained at similar levels and even lower than before. We're at about 64, 65%. Now we're averaging at about 58 to 62. So we're handling more requests with the blue machine. We're doing it faster in terms of response time while maintaining similar and even lower levels of CPU utilization. So again, it's easy to see how if you compound this to the entire cluster, the effect in capacity reduction could be massive. Because if you're auto-scaling based on CPU and throughput, and the CPU drops so significantly, you'll be able to run more load on less amount of machines, or just meet your SLA faster, or improve your revenue if your revenue is tailored with response time or throughput. Just to show you the full process, deactivation of the agent is exactly similar to activation. What happens here is that the agent will just unloads gracefully from the queues at the runtime level, and everything goes back to normal. We're not replacing your runtime. This is just reprioritizing on top of the runtime decisions. So it's immediately as the agent is deactivated, it just unloads, and everything goes back to normal. So we saw that right at activation, you see a significant and consistent performance optimization or performance improvement, and it is visible in both throughput, latency, and CPU. So what I showed you right now is what happened behind the screen, because this is a more tech audience. I showed you what actually happens when you activate an agent. But when you actually activate, you get access to a more robust UI from which you can control, deploy the agent, and actually view the results. So I gave you one example here of a customer that deployed this agent on one of its big data cluster, a Spark workload running, for example, on its cluster. And you can see the moment of activation where the cluster tuned to gold, where the agent is actually performing optimization, the reduction of capacity is massive and immediate. So immediately after the activation, we were reduced from about 5,100 cores average over that time to about half that number right after activation, automatically by the performance optimization. Just to show you, you can have full visibility into the overview of the cost reduction you're getting. The deployment per workload is super easy. The agent can be deployed in a CLI command line, whether you're using Docker containers, Kubernetes as a daemon set, EMR, ECS, however you're deploying, you can deploy the agent and get significant performance optimization really fast. You also have container view for Kubernetes clusters, or just to show you an example, again, another example, just to show you a service which is not big data, for example. We usually benchmark the results of the agent by providing a 50-50 comparison. We activate on one cluster 50% of the agents, and then leave the other 50 passive. And then you have a comparison between active and passive instances directly on the UI. So you can see, for example, in this service, which is an ad tech service, you get a throughput increase on the active machines of about 30%, lower latency per machine, and lower CPU, which allow this customer to manage the same amount of load with about 30 or 25% fewer capacity to run the same cluster. You can also control, activate, and deactivate the agents directly from the UI. Very easy to control, just to show you the full process. Now, after we saw the agent, I want to also walk you through the GProfiler. We talked about it briefly. The GProfiler is the tool, an open source tool, that provides you the ability to profile your code over time, get visualization of your code, to identify inefficiencies on your own without any relationship to the agent. So just to show you an example, again, the GProfiler open source tool, you can see the full code on GitHub. You can also access it if you want at profiler.granulate.io. But what it does is that, I'm not sure if everyone here is familiar with the concept of flame graphs. It samples the CPU of a machine over a period of time, and then provide a visual representation of your code over that period. So for example, let's take the last week, for example, instead of the last hour, and then you can see each of those stacks you're seeing on screen is a process or a function running on your machine. So now, a lot of our customers are using this tool to identify inefficiencies in their own. So let's say I'm taking a Python workload, and now a customer might look at this and say, OK, my handoff between my Python application and my kernel syscalls is taking about 9% of my CPU. Why is it so high? What am I doing wrong here? Why is my line of code not efficient enough to run this smoothly and to make it, as I expected it to take, less than 5% or 3% of the CPU? You might also look at a Kubernetes cluster. And for example, look at the cluster and say, my kubelet or my Docker Ds are taking combined about 15% of my CPU. What am I configuring wrong here? Something is wrong with my application. I can fix this without going to a full rework or a full motion of cost reduction just by looking at my flame graphs. Just to show you an example, I'm sorry, just left the screen. I need to log in again. But one of our customers, for example, deployed the profiler without deploying the agent at all. Let me just log in a second. You can see on the screen that, for example, this customer looked at the graph and saw that, for example, his garbage collection allocation is taking a significant amount of the CPU. About 39% of the CPU of the machine goes for garbage collection handoffs. So what he did, for example, is change the configuration of GC independently, make less GC runs on the same period of time, saving him about 20% of CPU utilization without affecting performance at all. So this is fully available by looking at your code in a visual way. And also what's interesting here is that this is aggregated over time. Most flame graphs or profiling tools are a one-time thing. You need to run it one time. You get a snapshot of your state. For the profiler, you get an aggregated state across time. You can see, for example, I can look at 1 week, and then you can see over time which of the lines of code or my processes are taking the most amount of resources required. So again, this is a significantly strong tool for CI/CD dev teams or dev teams in general to find inefficiencies and incorporate optimization and efficiency to their general processes on the cloud. Just to look at the deployment, again, similar to the deployment of the agent, very easy, seamless to deploy, easy to control, Docker deployment, Kubernetes, command line, OpenShift. Again, this is open source. You can try it out on one machine, see if it works, and then decide what you want to do. I want to say that the profiler, besides giving you, for example, I'll show you an example here. You can get actual heat maps of which processes or which functions are taking the most CPU. You get recommendations into inefficiencies that the profiler already knows of, and then helping your team to find inefficiencies in their code and improving performance. Now we're looking at the third tool that we discussed before. Again, we discussed the agent, the real-time optimization agent that allows improving performance real live on the OS level. We talked about the profiler that allows you for profiling your code and finding inefficiencies. And now we're going to look at the third tool, which is called gmaestro, as I mentioned before. Gmaestro is a tool that is also available directly from the UI that allows you basically to get right-sizing or orchestration recommendations live under your control and the logic you choose. So for example, let's say you're a DevOps manager or infrastructure lead, you're trying to reduce your reservations because you know you're over-provisioned, and you want to maintain a specific logic. Let's say I want to make sure that I don't cross the max of my cluster utilization CPU over the last 3 days over 30%. You will automatically get recommendations into how you can reduce the CPU request, memory request, change your HPA to meet that logic while saving you a lot of costs along the way. So this tool can automatically, first of all, the agent can automatically make those changes for you if you choose to do so. Then you choose a logic, 30% over max, and then that will keep that way over time. Or you can simply apply directly from the UI. You can look at the recommendations and implement them manually. This will cause you some work, but will leave control over you. You can also have apply here. Just get immediate apply YAML file to apply on your cluster and make the change automatically with low effort. All of those will allow you to, over time, maintain that cost reduction and allow you to get more reservation changes based on your actual utilization. So you don't need to stop and make a full right-sizing efforts every couple of months. You can just maintain with the same logic and keep reducing your costs over time and allowing you to get to the sweet spot much lower end. Again, this is completely open source as well. You can use this whenever you want, free of charge. We usually, when the process of working with Granulate, after you get the performance optimization from the agent, the gmaestro will kick in and allow you to reduce more capacity. Because now you're running with lower utilization of resources, lower CPU, lower latency. This will allow you to manage with the gmaestro and reduce more capacity and instances. Awesome. So again, with all of those, 3 of those tools, what Granulate allows you to do with that motion of improving performance to reduce costs instead of cost optimization tools or right-sizing in general, is it allows you to first improve your slope of going down into the sweet spot that you want to get to, with sweet spot of cost over performance, and also allows you to reduce that sweet spot or improve that sweet spot more than you think you can. Because most of the times, again, you're in a mental state where you feel stuck. You cannot invest more resources to save costs because this will be extremely not beneficial. You will invest a full team for a couple of weeks to maybe get some cost reduction for right-sizing. And Granulate will allow you to reduce that performance optimization or reduce that inefficiencies and allow you to reduce more costs overall. So how we do that? First of all, with the profiler, allows you to, over time, save more and more costs by identifying inefficiencies in your code very easily. The agent will allow you, even if you already went through a full motion of cost reduction, you have reworked your code, you have managed right-sizing, you did orchestration tools, you've, however you're trying to save money, you move to spot instances. However, you can still get an additional 30% or 40% of improved performance by using Granulate because of our, we are approaching performance optimization from a very different layer of the stack, which is OS level, runtime level optimization in general. So again, this is an ability for you to reduce your sweet spot or lower it while improving your slope and allowing you to get more cost reduction. So I think that you're probably thinking right now, is this even relevant to me? I don't know, maybe I have a Kubernetes cluster. Maybe I have a big data workload. Maybe my cluster is super dynamic and spiky, and my load is never the same as it was yesterday, and the learning of the agent is irrelevant. Or maybe I'm currently in a hybrid scenario when I'm moving from on-prem to the cloud, or I'm on both scenarios, and I'm not sure how I can use those tools. I just want to say that, first of all, because the agent operates at the OS level of the machine, we're completely agnostic to the infrastructure. Whether you're on it fully on-prem, fully on the cloud, big data, Kubernetes, as I mentioned, we support EMR, Fargate, Kafka, ECS, EC2, however you're deploying, it's super easy to get optimization either way. Even if your cluster is dynamic and has spiky workloads, the agent can adapt to that and provide more value over time. I'll walk you through some examples from customers in a couple of slides. And we support on-premise and cloud all the same. Maybe you're asking yourself, I'm auto-scaling not based on performance metric, not based on CPU, but I'm auto-scaling based on memory, or auto-scaling based on applicative metrics you don't even see. So even if you improve my CPU by 30%, I still can get cost reduction out of it. So you're right. If you're auto-scaling based on another metric, or your cluster is fully static, performance optimization might not lead automatically into cost reduction. It will require another manual effort. This might mean you might be able to move to a more memory-bound type of instances at AWS. You might be able to manually reduce instances based on the free up space you have on the cluster. You might be able to change your auto-scaling thresholds to scale out less over time and reduce costs, but that leeway or improved performance will allow you some way to reduce your costs either way, and it will help you do that also. And you might be, as I mentioned before, at different stages of the hierarchy. Might be a startup that doesn't care at all about costs. You only care about growth, and you don't care about performance at all. Or you might be a super large enterprise with every process is in place, and you have very quick headroom between your initial state and your sweet spot. Either way, you can get value out of it, because even if you are a startup, you can go through that motion of cost reduction much more easily without any manual effort. The profiler, the agent, and the gmeister are all fully self-service. Part of the motion is to try to make this process easy to use without you needing to invest any manual work. You deploy a tool, it gives you either recommendations or just improve the performance live for you on the cluster without needing to invest a team or efforts at all. We talked about the deployment process. We can deploy pretty much on any type of cluster. Super easy to deploy, easy to integrate. And we talked a bit about the spiky loads, and I will show you some examples in the next couple of slides. So now I'm going to walk you through a couple of examples from customers. I, of course, anonymize them, but just to show you how this actually translates to customer environments of performance optimization. So looking at the first one is a retail and e-commerce company of over 5,000 employees in Southeast Asia, if you're interested, running with a Go service on AWS. So they're a very advanced company with state-of-the-art right-sizing, full teams dedicated to reducing their costs, and they hit that saturation point. There was no effort that they were willing to invest to get cost reduction, but because it cost them a lot of time, a lot of efforts, and the potential gains in the end were not clear or even not really relevant for them in terms of cost reduction. So they've deployed Granulate, as I mentioned before, with the process we've seen. Deploying the profiler, they got analysis of their code and identified a few inefficiencies. And then they deployed the optimization agent. And then going through the same learning process I showed you before, there was a reduction of 30% of the CPU utilization of two of their clusters. You can see this example here, GraphQL service on the right side. You can see the active machine out of the 3 machines are performing much better than the rest of the machines, consistently so. The left side, you can see a 50-50 comparison between about 200 instances active compared to 200 instances of passive. And you can see the reduction in CPU, which is consistent and significant. Again, they leverage that to automatically reduce about 30% of their capacity. Again, this is a customer that was very well at the saturation point. There was no more efforts it could have used in its current bucket of solutions to reduce costs more or improve performance. It has already used right sizing, already reworked his code, and is already investing a lot of team members to reduce cost, but still got an additional 30% from that solution. Now going through an example of an autonomous driving company that deployed us on their big data workloads on AWS, again, running with over 100,000 cores on the cloud on big data. They deployed us on, I would say, 20 different services, which were running at significantly high job completion time over time. And by utilizing Granulate with the same process we saw before of profiling, then deploying the agent, then right-sizing, they were able to reduce the job completion time by over 40% on average across all of those jobs. Again, job completion time is one-to-one transferable to cost reduction, because if it's an ephemeral cluster, you just run your job for less time, you're paying less to AWS or the cloud, or if it's not, you can just reduce instances, run the same amount of jobs with just lower capacity. And they utilize that to reduce the amount of instances they need to go back to the same job completion time as before and reduce costs. Again, the point here is that these are very well-established and well-optimized companies with significant workloads and costs on the cloud, with no really way to reduce costs more without trying to break everything and build it up together again from scratch. And this is a very low effort, about 10 days the entire process took to bring them to this 45% reduction in capacity and costs. This is just an example. Just, again, another example is an online gaming company. This should exemplify to you what happens if you're running a spiky workload. We have a company, a gaming company running on AWS with over 800 employees. Their games are managed in Java and Node.js. So they have very spiky load in terms of that once a week, their traffic hits 100x than their usual load over the week. They're running 10% CPU, and then once a week, they're 100% for about a day with significant amount of cores. What's interesting here is, again, they got, by using the agent and the GMaestro, about 40% throughput increase and CPU utilization, which allowed them to reduce about 40% of their capacity. What's interesting is that even when they scaled out to the most advanced or the most high-scale game or event, the percentage remained the same. CPU utilization of 40% was the same with a 10%, reduced to 6, and when you were at 100% CPU, reduced to 60. So their capacity, the ability for them to save capacity and save costs remained the same, but meant a lot more cost reduction for them over time on that cluster. So again, even if you are running at super dynamic environments, maybe a Kubernetes load that you have multiple pods per node, each a different microservice, each of them with different patterns, the agent can still provide value and improve performance either way, and you can leverage that to reduce your capacity significantly. Just to show you, this is from their own APMs. It's from Datadog, if you're not recognizing. Sorry, it's a bit blurry, but you can see on the activation state, I have a laser here. You can see right the activation, you can see an increase in the outbound traffic or throughput per machine, a reduction in CPU, and a significant reduction in latency, which again allowed them to automatically reduce capacity and save cost, even though there was a very well-optimized solution. So again, talking about the journey, which we saw in a few customers, start with profiling their code, getting potential bottlenecks solved by looking at their code and finding inefficiencies, deploying the agent to start the real-time optimization at the OS level, and then allowing them to reduce costs by managing capacity better, either by GMaestro or just triggering the auto-scaling event and reducing capacity. All of this, by the way, if you saw the deployment process, happens with very low effort from the DevOps teams. Deployment takes like 5 minutes, either as a daemon set CLI command line, and then you're off. GProfiler works automatically, identify inefficiencies or allow you to identify inefficiencies, and the agent will automatically create value without you needing to do anything, and we just need to meet to review the results later down the road. Same goes for GMaestro. Cool. So let's talk about the takeaways from the session. First of all, we discussed the pyramid or pyramid of needs of DevOps or new application running on your cluster. First of all, you need to understand where you are in that pyramid, whether you are holding yourself back from moving to more complex cost reduction initiatives because you are currently afraid, you're trying to make sure the application is up and running. Maybe you can set free and start using your low-hanging fruit cost reduction capabilities. Maybe negotiate your contract, maybe use spot instances, maybe do some best practices in your code. But once you understand your point in the pyramid, if you understand you've reached saturation, then try to think of what is my current sweet spot? Am I actually in a sweet spot? Can I make some efforts to make my sweet spot lower in terms of the relative cost to my cluster. Maybe, again, I'm afraid I'm not moving forward. Maybe I can stop right here, and it's not worth for me to invest any more resources. And then strive to integrate automation, optimization to your general processes. If you just wait for the last pillar on the hierarchy to start using optimization, you're missing out. You can do a lot of cost reduction very easily throughout the process to achieve much more cost reduction with, for example, tools like Profiler and the agent, etc. But you can also do it on your own. You don't need to wait for feeling fully comfortable before you're using the more complex tools and optimization. And again, as an agenda, try to think of cost reduction from the perspective of performance optimization. So don't only use cost efficiency or cost optimization tools that reduce capacity or turn off instances that are underutilized, but try to look at how can I improve performance by improving my code, by improving my OS level resources, and then leverage that improved performance to reduce your capacity even further. This is a very different approach to cost reduction, but it can help you if you reach a saturation place that you cannot find any solution in the market that can give you more out of the current bucket you already probably used on your company. And try to improve your sweet spot by thinking outside of the box, using Profiler, using the agent, maybe using your own optimization or right-sizing tools, just to see if you're actually in that sweet spot, or you can reduce it even more to improve performance. I'll be here for a few minutes if you want to ask, but thank you so much for the time. Thank you.